Welcome back, AP. Oh, man. So we are now moving into probably two of my favorite things to teach about in all of European history, right? The scientific revolution, which is predominantly about space, which freaks me out, but it's so cool at the same time. It is a massive, like, I don't want to say hiccup, but like a huge turning point, game changer in all of European history, right? So, and then you also have the Enlightenment, which is the game changer of the scientific revolution. So many people say that the scientific revolution had to happen for the Enlightenment to happen, right? And that's going to be your game changer in all of your European politics, right? You're like, like for like us, like moving ourselves forward into like more positive political spheres and kind of giving us everything that we know about politics and understand about freedom of or rights of people today, right? So now getting into it, though, I am trying to keep this flip below 20. No promises, Shane. All right, so getting after it, though, let's pick back up where we're talking about the scientific revolution. Oh, also, let's be honest. This is adorable, right? Scientific revolution, beaker, bubbles, enlightenment, light. Yeah. Good stuff, I know, right? And look at this. The slides are in the bubbles, right? So we picked up right here when we were talking about this stuff in class. Now, some people like, Haley, I'm sorry. You're just going to have to bounce back a little bit. But yesterday was meant purely for me to see what you know. All right? So, like, I just needed to see what you know. 9 times out of 10, when kids bring up certain ideas, it's the stuff they know the best, right? And I saw a lot of great things. Couple overlaps, a lot of great things, though, okay? So you guys already know a huge chunk of this stuff, all right? A huge chunk. So let's get after it and kind of buff those things out and add a little more depth to these chunks and then make sure that you understand the importance of the mid-1500s-ish, right, all the way up until like 1700s Europe when it comes to scientific thought and the progression forward, right? Well, whenever you're talking about these people, you got to start with your base, right? Your base, where you're working out of. And that's your natural scientists or your natural philosophers, right? A lot of people like to say natural philosophers. I like to say natural scientists because everybody's like, well, the word science was not invented until the mid-1800s. Well, shut up. All right, so anyway, but a lot of it is along the premise of people that can kind of walk out into the natural settings and just say, why is the sun that color? What's light do? What's that do? What's that curtain made out of, right? Like, so how's this plant grow? All right, so like all kinds of stuff like that. That's your natural scientist, right? Questioning the tangible, the observable, right? Well, we talked about 3 in class. You only really need to know 2, all right? So first of all, let's talk about what natural philosophy or natural science is, right? According to like the Wikipedias, which I don't care what anybody says, it's a great source. Tell them to be quiet, all right? So now it's the study of the natural world and the earth as a precursor to modern science, right? Now, modern science has like a lot of different properties all mushed into one, right? Like alchemy now being chemistry, physics in the physical realm, organic versus inorganic biology, like a lot of amazing things, right? Well, not inorganic biology, that doesn't make any sense. More like environmental science and the principalities of biological ideas all meshing themselves together makes our field of science today, right? Well, the thing about it is, we talk about 3 particular ones already, but let's get after it. You only need to know 2, all right? I like to talk about 1 because he's funny, all right? So now, Aristotle, Archimedes, Ptolemy, right? Now, Ptolemy or Ptolemy is important, right? His Almagest is a pamphlet that he wrote, okay? By the way, in this presentation, there's going to be a lot of pictures and not a lot of words on the screen, and you need to get ready and just buckle in for it, all right? Write down what you think's important. We'll review the big important pieces on Monday like we always do. All right? So, and we'll get after it then. Aristotle is the other really important natural philosopher that you need to know, all right? So, Archimedes is just fun to talk about, right? He runs out of his bathtub naked when he tries to figure out if a crown is made of gold or not. If you want to know that story, ask me in class, and I'll tell you the whole thing. It's actually pretty funny. Now, anyway, but Aristotle and Ptolemy, very important. I like to talk about Archimedes for a second just to kind of discuss things like his abilities of mathematics, right? Like his ideas of looking at the world for what it is, making depth rays, using like things like the sunlight, which actually doesn't work when we've tried to reconstruct it, but it's whatever. He invented a claw, which was kind of cool. This giant like thing that was supposed to be a military protection for the city-state of Syracuse, of which he is actually from, that would go down into the water and grab a boat and like shake the upper 11 daylights out of it, right? So Archimedes also invented a screw, which is the very first modern well that actually carried water from one level to another. A lot of amazing things. He even also like postulated ideas of mathematical areas of irregular shapes, right? So this is called the method of exhaustion, a theory that he kind of like lurched forward. Like Euclid came up with it first, and then he actually kind of kept pushing it. So like when you have an area of an irregular shape, you can't just like take an area of an irregular shape because there's no actually like formula to figure out the area of an irregular shape. So you have to make smaller figures inside of that irregular shape and then find the area of that and then add it to the other smaller ones. And as you break it down further and further and further to the nth degree, that n, when it becomes infinitesimally small and we're just not that worried about it anymore, it's kind of like the area of this irregular thing, like this top of a parabola, right? That's the method of exhaustion. So Archimedes is just really cool, right? So now getting after it though, when we're talking about the scientific revolution, it all has its precursors in one huge concept. Where the heck are we in the universe, right? Aristotle and Ptolemy's ideas both center around a geocentric model, right? That the Earth is a stationary object that's just straight chilling and everything else is running around us, right? Aristotle's ideas are that it's in perfect rings that actually go around us and then everything's flying around and that there's this big band of stars to the outside, whereas Ptolemy's idea in his Almagest, which is the only surviving scientific text from the the era of antiquity, right? That's the word I'm looking for. Now, his Almagest is good stuff. Some of the math's wrong. It's all pretty much wrong because, like, you know, like his original, like, his geography is another book that he actually wrote. It didn't have the other two continents in it, and it wasn't proportional, and it only had, like, the top third of the world, and like, so he came up with a lot of amazing ideas, though. A lot of amazing ideas about, like, the movement of stuff and, like, the orbits, period. That's a good thing, right? So now he's operated with spheres, though. It was this idea that, like, the stars were a giant ball around us, and then, like, there were just smaller spheres inside of it, and these little crystalline spheres that, like, keep the things going around us, right? And that everything actually moves around us. So here's the thing about it, though. They also tried to find a way to explain, like, why everything here is, like, stuck to the world, right? Why, like, this, like, for example, like, why this book falls. Or, like, so, why, like, this? Like, why does this happen? Like, so, this is a really big, important thing, because they refer to everything outside of Earth, as perfect matter, right? Perfect matter, stuff that kind of goes to the sky because it is weightless and perfect, right? That the heavens are made of specifically designed perfect materials. Underline this. It's very important, all right? Perfect matter. Just, right? And then everything here is hot garbage. Like this, I'm not going to break that, actually. This is my favorite mug. Now, like, so perfect matter resides in the heavens. Everything else here stinks, and that's why it's drawn to this trash in the middle, right? Corruptible crap. The other thing they came up with is this thing called epicycles, right? Epicycles are orbits within orbits, right? To try and explain something along the veins of this stuff called, like, retrograde motion, which we're going to get into in a minute. We're going to talk about why astrology is dumb. Now, anyway, so getting after it, though, epicycles is what they use to try and explain the minor marginal differences when you're looking into the sky to explain the movement of the planets and how every now and then, you know, like, they'll move a little bit, right? So looking at this right here, this is an epicycle, right? The epicycles were like the Ptolemy's model of the universe. It's that Earth is here in the middle, and the moon moves around us first, and that, like, Mercury and Venus go around us like this, but then they're also moving on their own orbits, and the only one that's not actually moving on an epicycle of its own is the sun, which is just kind of hooking its way around us and just doing its thing all the time, right? Do you blame them? I don't. I mean, they didn't really have any other way to figure this out, or like, whatever, right? So now here's the other thing, too. When we're talking about those two models of the universe, they then became kind of canonized and, like, specified in Christian lore, right? So as time would roll forward, it gave credence to the idea of intelligent design and the idea that the Earth is at the middle, and it was the idea that was propagated by the church, right? Was the idea of the Aristotelian or the Ptolemaic model of the universe, right? That everything else revolves around us and that we are here in the middle and that everything here is, like, as a invention of God, right? So just keep that in mind. Especially when you think about the fact that the scientific revolution is not as clean cut as you think it is. This guy, looking dope as heck in his hood and garb, is Giordano Bruno. Right? Giordano Bruno was an Italian philosopher and scientist who actually was one of the first people to theorize the idea of a heliocentric orbit, right? Giordano Bruno was like, hey, I think we go around the sun. I think all the other planets do too. Because when you think about it, the thing's huge, right? Like, so, also, here's another crazy thought. All those other bright lights at night, those are other suns that might actually have other planets going around them. Like, huge record scratch, and then the Catholic Church burned him alive. All right, so, like, this thought brought up by Copernicus is not as groundbreaking as everybody thinks. The big thing about Copernicus's ideas is it tried to explain something that no one else could really explain, and also not to mention the fact that he was very, like, educated. He went to 4 separate universities, starting his entire career at the University of Krakow, and then going to the University of Padua, and then ending up at the university, I think, in Florence, right? So, why am I asking you if you're right or not? But 4 separate universities, could speak 5 different languages, was very, very well-versed, and a very good writer, all right? So, now the thing about it is, he wrote his premier work called the De... All right, so I can't pronounce it correctly in Latin, but it's The Revolution of Heavenly Spheres is the name of the book. Good job, Laura, for knowing that the other day in class, or yesterday in class. Now, here's the thing getting after it, though. The Revolutions of Heavenly Spheres is great. The hipsters refer to it as De Rev, right? So, anyway, somebody's going to put De Rev in their notes. I guarantee it right now. De Rev. Oh, so cool. This right here is your man Copernicus, right? Polish-born, German-speaking family. The big thing about his nationality, a lot of the Czechs claim him, right? Or, like, not the Czechs. A lot of the Polish claim him, right? So, biggest thing about Copernicus is he's going to shatter the world when he tries to explain one giant flaw to the Ptolemaic and Aristotelian, like, principality of the world. It's called retrograde motion. Have you ever heard a hippie like my wife, for example, who's like, you know, everyone's acting so crazy right now. Mercury is in retrograde, and it's just sending my brain all over the place. Okay, retrograde motion is when we observe from Earth the movement of the planets, and they're hooking back and forth, right? Now, that actually has much more to do with the size of their orbits versus the size of our orbits and our orientation in our solar system, right? When we observe other planets at different times throughout the year, they move like on a zigzag almost, right? The one of Mars, actually, when it comes around, it goes like this. Oh, wow. And it like just like hooks a U and then goes back down again. So, retrograde motion was unexplainable by the Ptolemaic and the Aristotelian ideas. Also, the Ptolemaic and the Aristotelian ideas threw all the calendars off, right? The Julian calendars that were being used at the time were like 10 days off, like all the time, right? They were always days and days off. And like farmers were the ones who actually knew more about the solstices and the long days of the year than than academia, the sphere of it, did, right? So, first of all, let's take a break from all this stuff, right? Screwed up calendars, retrograde motion, and how his, like, theories are going to actually fix everything. And let's talk about his doppelganger in entertainment. Right, Lord Farquaad from Shrek. He looks just like him. Now, getting back to him as a person, though, this is, of course, the Copernican model of the universe, right? The idea that we are in locked orbits around the sun. Now, of course, this is going to present some problems as well. In De Rev, in the first 24 pages, he explains his ideas, and then for the rest of it, it's a lot of garbage math that doesn't make any sense, and then like the idea that he still thinks we're inside these crystalline spheres that Ptolemy and Aristotle like actually emphasize, because they're like, well, it's like, it doesn't make any sense. Why does stuff fall here? That's dumb. Your ideas are stupid, right? So everyone discredited this guy's ideas. He actually died holding his first published copy of his book, De Rev, in his hands. He had De Rev in his hands, and he was like, I did it. And then he just, like, died, right? So he didn't even actually ever get to sell his book. And the implications of it ain't even going to show up until 60 years later, right? However, he offers a new idea, right? So that splits the scientific community, and in doing so, creates a void for people to argue, conjecture, and push their ideas forward, right? Now, getting after that, let's talk about how the scientific community progressed forward. Now, we will end up hopefully getting to the end of Kepler possibly to the end of the Galileo if I'm lucky. Let's keep moving. I'm trying to keep this thing not crazy long. But this is like all pictures, so you're going to need to pick up the stuff that I'm saying. You should have wrote down retrograde motion, and the calendars were off, and the Copernicus model is like blah, 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 blah. Day rev is important. All right, so then we got this guy. It's either Tycho or Tycho. I always say Tycho, but I think it's Tycho. Now, Tycho, whatever you want to call him, I really don't care. Brahe is actually a Dane, right? He's a Danish scientist, madly wealthy, dummy wealthy. And his big stuff is going to be about how a star is born or dies or one or the other. All right, so, and yes, it's supposed to be a play on the movie that came out recently. But let's talk about this guy for a hot second. All right, so independently wealthy, fabulously wealthy at that, right? Mathematician, extremely intelligent. Got into an argument with his cousin over a math problem, challenged him to a duel, and in said duel got his nose sliced off, right? He actually would create prosthetics out of, like, different types of materials. He had a gold one, apparently, at one point. And he would use wax and then, like, stick it onto his face whenever he was going to parties. And if he got really frustrated or too excited or, like, drank too much and started sweating, it would, like, fall off. So you know the night's getting crazy when Tycho's nose falls off, right? So very wealthy. He actually even establishes an independent research facility off the coast of Denmark on an island all of his own, right? And on that island, he builds like 2 fortresses, right? One towards the day, one for the night for like astrological observations. The thing you need to write down about Tycho is the fact that, or Tycho, whatever, you need to write down the fact that he did not agree with Copernicus, right? He actually advocated for the Tychonic system, right? Which is wrong also, but still. All right, so his Tychonic system said that it was still geocentric, that the Earth was still actually in the middle of the entire system. The moon moves around us and the sun moves around us, but then everything else actually moves around the sun, right? Now, the problem with this system is that had they progressed forward with the slight margins of error and different things like that, the planets would have ended up colliding with each other at some point or another. Now, but here's the big contribution that Tycho gave, right? 2 things. 1, observation. Tycho literally would stay up all night long and just look into the stars, and he actually documented the location and movement of over 777 different stars at any given point throughout the year. So just buttloads of data, like just so much data. Like the guy literally wrote down an obscene amount of stuff. But then also something you need to know about him really quickly is his observation of one particular thing, all right? He noticed something. Remember when we talked about perfect matter, right? Perfect matter, the heavens are made of perfection and all the garbage is here according to Aristotle and Ptolemy. When looking out into the stars one evening, and I believe it's in the constellation of Cassiopeia, but I'll have to double check it, he saw something explode. Now, keep in mind also, he is the last preeminent astrologer to not use a telescope. He did this with the naked eye, right? He was just looking at it like this. And then in the night sky, a star that he had never seen or accounted for, burning brighter than any of the other ones he could see. He either saw one of 2 things. He either saw a star being born, right, or a star dying. Now, giving off that much light shows, and he also documented it over a year, and then eventually when it went dark, he was like, wait a minute. The heavens are not made of perfect stuff. The heavens are exploding and crashing and destroying each other all the time, right? He's going to write all these things down. He's going to issue one book, De Stella Novella, right? So, which is actually like, De Stella Nova, like the beautiful star, whatever. Like, so where he actually documented this particular nova, right? So the biggest thing about him, though, is after trying to do all this stuff in Denmark, the king that actually supported him at the time would die, and then he would be exiled. Like Tycho would actually be exiled because he was spending too much money. He'd be exiled to the Czech Republic, into Prague specifically. And while in Prague, he brings all of this data. One of the most particular things he tracked was actually the movement of Mars, right? So, and then he meets this cat, Johannes Kepler, a devout Lutheran and a very great interpreter, right? So he actually's biggest thing that he contributed to this entire movement was the taking of Tycho's data and actually figuring something out with it, right? He also agreed with the Copernican model. He was like, you know what, we're moving around the sun. Let's all get over it a little bit, right? So the number one thing that he actually did he earned Tycho's trust and gained access to all of his information, right? Tycho would actually die a few years after these guys had actually met, right? And then following this entire thing, they had gotten into a couple of arguments over math as well. Don't worry, he didn't cut any part of Tycho's body off. Like his nose was already gone. He wasn't going to get into all that again. But Copernicus was a great interpreter of data. Whenever he would try to come up with original ideas on his own, they kind of always would fall flat. This being one of them, right? So he actually came up with the Kepler solids, this idea that there are all these shapes that perfectly make other shapes, right? Now, if you do this the right way, you can basically make a lot of rounded shapes, geometric shapes, out of 6 different shapes, right? Circle, triangle, square, like a pentagon, hexagon. I think it goes up to like a dodecahedron or something like that. All right, so but you can make these perfect little shapes. But he noticed you can make 6 of them. Wait a minute, there's 6 planets. Maybe this is the design of the universe, and they all sit and they nest inside one another. Nah, 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 nah. And he kept going. And he would eventually realize later on that didn't make any sense. It was just a coincidence, right? So this is one of his earliest models of the universe. It doesn't make any real sense, but we think it's just kind of cool. You know what I mean? So, I don't know. I'm going to get that tattooed like right here on my face. Now, the biggest thing about it, though, that he's going to notice is he's going to keep just scouring and scouring and scouring through all of Tycho's data that he had actually observed, all these different stars throughout these years, and just looking at it and looking at it. And the thing he could not put a finger on is the retrograde motion argument, right? He was like, I know that Copernicus is right, but I can't figure out how to actually like really mark this thing down and actually figure out what it is that is causing this like looping of all these stars. And he kept creating all these new documents and all these new maps and all these new like patterns of the universe, and kept looking at it and looking at it and looking at it. And keep in mind, Kepler was a phenomenal mathematician. Phenomenal. Absolutely amazing. And he looked at it and he looked at it and he was like, should I go back to the basics? The idea of an oval-shaped orbit was considered too simple for all of the preeminent like philosophers that came before him, right? All the scientists that came before him said, oval-shaped orbits, that's dumb, right? That's too easy. Let's throw that idea out altogether, right? It turns out it was the right one. So Kepler, what he's going to do is advocate for the elliptical orbits of the planets, which basically fixed all of the problems when it comes to retrograde motion. He also came up with several different laws on retrograde motion. First and foremost, the fact that like it actually does not move on one axis alone, because everybody was like, well, how is this going to happen? Right? There's one axis. It's one axis. You got to go in a perfect circle. He advocated that there was actually 2 focal points, right? 2 focal points that if you were to take 2 nails and shove them into a wall and put a big thing of string on it, you would actually come around in big ovals like this, right? You would actually end up poking back and forth. He also advocated for the different speeds, right? So he advocated that the closer we are to the sun, the faster that we're actually moving, right? We are picking up speed the closest we get there, and then we're hooking back around again. And he did this by finding area speeds at different locations throughout the year, right? Using different, like, stellar parallaxes of stars that were off in the distance, right? We'll get to that stuff later. But the thing about all 3 of these big heavy hitters and their ideas is they're just going to completely change the game. You've got, quick review, Copernicus offering up the idea of a heliocentric model of the universe initially, and then dying immediately afterwards, right? And then you got Tycho studying the locations of the stars. And then you got Kepler, the great interpreter, the synthesizer, bringing all these ideas together and creating the actual legitimate model of the universe with elliptical-shaped orbits that explains everything, right? Using it to try and figure out the like rotation of the Earth and stuff like that. And actually it like, he also conjectured that it had an axis as well. That like Kepler was like, well, there's a third motion. It's on an axis. All right. So these 3 men are going to change the game. Kepler, given the credit, there's a huge dispute over if Kepler should be given more credit than Tycho, because did he actually steal Tycho's ideas and all this other stuff. But amazing figures in and of themselves. Now, getting into class on Monday, because I'm not going to sit here and talk your ears off, all right? We're going to talk about Galileo, Bacon, and Descartes, all right? And then we're going to pick up a couple other guys later on. But you guys are killing it. I really, really like it. One suggestion for this, I know it's like 24 minutes. I'm sorry. One suggestion for this one, though, is you don't even necessarily have to watch it. Watch it. Like, put it on in your car, listen to it like it's a podcast, do what you got to do, right? But the big things that you got to understand is where all these ideas came from, right? So, and like how these simple ideas thrown into the fire are going to kind of illuminate the world. Ooh, that was a good metaphor. So they're going to illuminate the world and kind of cast a new idea out there, even though they were still at this point by the church considered heretical, right? So, but we're going to stop there. That's going to be your weekend. Go Birds, baby. Beat the Cowboys. I will see you guys on Monday. Y'all have a good one.